Boilers differ in many ways, but what they all have in common are miles and miles of boiler tubes, piping, and ductwork to carry various solids and liquids into, out of, or through the boiler. Now, with all of this equipment for conveying solids and liquids, it's a pretty safe bet that somewhere along the line, a leak will occur. In this part of the program, we're going to look at three types of leaks that are associated with boilers. They are leaks that occur inside the boiler, leaks that occur outside the boiler, and leaks that occur through the boiler casing. As you know, the inside of a boiler consists primarily of tubes. Water and steam flow through these tubes under high temperature and pressure. Every so often, the temperature and pressure takes its toll and causes a leak inside the boiler. For our purposes, we're going to divide leaks that occur inside the boiler into two categories, tube leaks and tube ruptures. The difference between the two is the quantity of water or steam released inside the boiler and the severity of the problems they cause. A tube leak is a small break in a boiler tube that allows a relatively small quantity of water or steam to escape. A tube rupture is a large break that allows a much greater quantity of water or steam to escape. A rupture can have a significant effect on the water level in the boiler drum and can directly affect the operation of the boiler. As you've learned, ruptures also have the potential for extinguishing the boiler flame. A boiler tube leak can occur anywhere there's a boiler tube. An operator usually has a number of ways of knowing that a tube is leaking. During a boiler inspection, for example, the operator may hear a hissing sound coming from the boiler in the area of the leaking tube. Depending on the location of the leak, an operator may be able to see the leaking tube when making a boiler flame observation. Instrumentation in the control room may also tell the operator that a tube is leaking. A difference in feed water flow to the boiler and steam flow leaving the boiler is one indication of a leak. Another is an increase in the makeup rate for the boiler, as indicated by this pen on this recorder. In most cases, a leaking boiler tube does not significantly affect a boiler's ability to circulate water or steam. However, a tube leak is an abnormal operating condition and has the potential of damaging the boiler if not carefully monitored. When a tube leak occurs, hot water or steam is released from the tube under very high pressure. If the leaking water or steam comes in contact with other boiler tubes, it can cut through those tubes and cause other leaks. If an operator isn't careful, a small leak can snowball into a major problem. A tube leak can also affect a boiler's ability to handle fly ash. Dry fly ash moves out of a boiler along with the air and flue gas on the way to the stack. Between the boiler and the stack, a fly ash handling system separates the fly ash from the flue gas. However, if steam or water from a leaking tube is sprayed into the gas flow path, it will turn the dry powdery ash into mud, causing it to stick to boiler tubes. The wet fly ash will insulate the boiler tubes and prevent efficient heat transfer, or it may clog the air preheater. Wet fly ash will also stick inside ash hoppers in the fly ash handling system. If the problem is severe enough, the boiler will have to be shut down and the ash hoppers opened up and cleaned. While the problems we've just mentioned can affect the operation of a boiler, in most cases a tube leak does not require an immediate shutdown. A tube rupture, by contrast, often does. A tube rupture can be caused by metal fatigue or result from a small leak that suddenly increases in magnitude. When a boiler tube ruptures, a large quantity of water or steam is released inside the boiler. This usually results in an immediate decrease in boiler drum level. Depending on the location of the rupture, a loss of flame can also occur. Tube ruptures generally occur suddenly and without warning. An operator must be ready to take immediate action. For the most part, a tube rupture requires an immediate shutdown of the boiler. This means the operator must shut off fuel flow and purge the boiler of all combustibles. Then, follow plant procedures for shutting down the boiler, tripping the turbine, and informing supervisory personnel and the load dispatcher. Of course, the inside of a boiler is not the only place that a leak can occur. Piping and ductwork that supply the boiler with the various liquids and solids necessary for normal operation can also leak. Any point where pipes are joined together or are connected to equipment or valves have the potential for developing leaks. The action that an operator must take to correct the problem will vary depending on the size, location, and severity of the leak. For example, most boiler drums have gauge glasses like this that can be used to check the water level in the drum. Due to the tremendous pressures and temperatures that a gauge glass is subjected to, leaks may develop. In most cases, the amount of water that leaks out of a gauge glass does not affect the operation of the boiler. The operator may choose to live with the leak until the boiler is taken offline for scheduled maintenance, or the operator may isolate the gauge glass by closing shutoff valves on either side of it. Once isolated, maintenance can be performed on the gauge glass while the boiler continues to operate. Once in a great while, a gauge glass may blow, spraying water and steam around the area of the boiler drum. This situation could endanger the safety of the people in the plant and the operator's ability to maintain proper drum level. The operator in this case has three choices of action to take. If it is possible to get to the isolation valves, the gauge glass can be taken out of service and repaired. However, if the leak is severe enough, the escaping steam may make it unsafe for personnel to attempt to isolate the gauge glass. If this is the case, the operator may be able to maintain the proper level in the boiler drum by increasing the make-up water rate. The boiler can then continue operating until it is convenient to schedule a shutdown. This being the case, the operator must isolate the area around the leaking gauge glass and inform supervisory personnel of this abnormal condition and the need to schedule the unit offline. If neither of these choices are possible, then the operator must take the unit offline immediately. Regardless of whether a boiler leak occurs inside the boiler or outside the boiler, the operator must make a decision as to the appropriate action to take. In most cases, the choice of action will involve isolating the leak and continuing to operate until maintenance can be scheduled. Or, if the leak is severe enough or endangers the boiler flame, shutting the boiler down. Once in a great while, a leak will develop in the boiler casing. The severity of the leak and the design of the boiler will determine the action taken by the operator. Balanced draft boilers, for example, operate under a slight negative pressure. For the most part, any leak in the casing will draw air into the boiler. Air leaking into the boiler through the casing can affect the combustion process, the operator's ability to maintain a proper boiler flame. If this is not the case, however, the operator can continue to operate the boiler until a shutdown can be scheduled. If combustion conditions cannot be properly maintained, the unit must be taken out of service immediately. Pressurized furnace boilers, on the other hand, present an operator with a different problem. Pressurized furnace boilers operate under a slight positive pressure. This means that a leak in the boiler casing may allow flame or hot gas to get out of the boiler. Flames extending outside the boiler casing can cause fires and create a safety problem for plant personnel. In most cases, a leak in a pressurized furnace boiler requires an immediate shutdown. In this part of the program, we've concentrated on problems associated with boiler leaks. We've looked at tube leaks and ruptures, which occur inside a boiler, leaks in equipment and components which generally occur outside the boiler, and leaks that occur through the boiler casing. For the most part, an operator has two choices for dealing with boiler leaks. If possible, the operator should isolate the leaking component and continue operating until the unit can be scheduled offline for maintenance. If the leak is severe enough to jeopardize the boiler flame or the operation of the plant, then the unit must be shut down immediately. In both cases, the operator must decide on the course of action and inform supervisory personnel and the load dispatcher according to plant procedures. Take some time now to read over this material in your text and answer the questions on boiler leaks. If you want additional information about the procedures used in your plant, ask your instructor to help you before going on. A boiler operates at specific temperatures and pressures. Unless the temperature of the steam is hot enough and its pressure high enough, the turbine cannot operate properly. Under certain unusual operating conditions, the pressure in the boiler may exceed the designated value for normal operation. If this happens, tubes in the superheaters and reheater may rupture, and in extreme cases, the boiler drum may rupture. To protect the boiler from overpressure, a special type of valve is installed in the superheater and reheater outlet lines and on the boiler drum on drum-type boilers. These special valves are called safety valves, and they protect the boiler from overpressure. Safety valves come in a number of shapes and sizes. Regardless of whether a safety valve is installed on a boiler drum or on a superheater or reheater, essentially, safety valves all work the same way. This is what a typical safety valve looks like. The basic components that make up a safety valve include a housing, a manual release lever, a spring, a disc, a seat, and both an inlet and outlet line. During normal operation, the spring holds the valve disc securely against the valve seat in the closed position. Pressure from the component where the valve is installed is exerted against a small portion of the valve disc at the inlet. As long as the pressure exerted against the valve remains within the designated value for the component, the spring will hold the valve in the closed position. If, however, the pressure at the valve inlet increases and exceeds the designated value, the increased pressure will push the disc off its seat. When this happens, pressure is exerted across a larger area of the disc, causing the valve to rapidly move to the open position. This is known as a safety valve lift or popping a safety valve. When a safety valve lifts, pressure is released through the outlet line, which is usually vented to atmosphere. Most safety valves are designed to close automatically. In order for a safety valve to automatically close, the pressure in the component must drop to a value below the popping pressure. For example, this safety valve is set to lift when pressure exerted at the inlet exceeds 2,000 psi. To close automatically, the pressure in the component must drop below 1,800 psi. Now that you have a basic understanding of how safety valves work, let's look at how they are used to protect the boiler from overpressure. As you learned earlier, the superheaters and reheaters in a boiler are designed to carry superheated steam at designated pressures and temperatures. The flow of steam through superheater and reheater tubes is important for a number of reasons. Steam flow is necessary to drive the turbine generator, to cause an efficient transfer of heat from the flue gas to the steam, and to keep the superheater and reheater tubes cool by removing heat from the tubes. If steam flow is stopped, the turbine generator can't operate. Also, unless an alternative flow path for the steam is provided, pressure and temperature inside the superheater and reheater tubes will increase, causing them to overheat, rupture, or even melt. To protect superheater and reheater tubes from overpressure and to provide an alternative flow path for steam, safety valves are installed in outlet lines of superheaters and reheaters. If steam flow to the turbine generator is cut off, the resulting increase in pressure will cause the safety valve to lift. This, in turn, will provide a flow path for steam, protecting the tubes from overheating. On drum-type boilers, safety valves are also installed on the steam drum. Safety valves on the steam drum lift if the pressure in the boiler exceeds designated values. This can happen when there is a decrease in steam flow without a proportionate decrease in fuel and airflow. If the demand for steam decreases, yet at the same time the boiler is being supplied with fuel and air at a rate greater than demand, the temperatures and pressure inside the boiler may exceed appropriate values for normal operation. In this case, safety valves on the steam drum may lift to relieve this pressure. There are usually a number of indications to alert the operator to overpressure in the boiler. Control room instrumentation will indicate increased pressure at the superheater outlet and increased pressure in the boiler drum on drum-type boilers. In addition to these indications, annunciator alarms will also sound to make the operator aware of the problem. Safety valves are necessary to protect the boiler from damage. However, they sometimes cause an operator some problems. The common problem associated with safety valves is leaks. As we've said, once pressure is reduced by the safety valve, the valve will automatically close. However, the valve seat or disc can be damaged when a safety valve lifts. If this happens, the disc will not seat properly and the valve may leak. An operator approaches a leaking safety valve in much the same way as any other leak in the plant. The operator must determine if the leak is severe enough to disrupt the operation of the boiler. If it is, then the operator has little choice but to shut the boiler down according to procedures. If, however, the leak is minor and the unit can continue to operate, then the operator must carefully monitor the safety valve to make sure the leak does not become worse and schedule the boiler out of service for maintenance. Take some time now to read over the material in your text on safety valves and boiler overpressure. When you're finished, answer the questions at the end of this part of the text. If you have any questions concerning boiler overpressure, ask your instructor to help you before going on.